Einstein was a prolific reader of history, right, and scientific literature too. He was influenced by, I don't know the name of the writer, but a man who was interested in going back into time, and he wrote it was not scientific, but it was science fiction about space and time, and he was influenced by that. That's kind of an interesting story.
Well, he has a great, I think with every creative guy, you're going to have some blazing insights, and you're going to figure out things like special relativity and E equals MC.
That's what I'm getting at. The fact that at the time Einstein was formulating his ideas, the world was in a place where there were other scientists who had similar ideas. So he probably learned a lot of what he knew from other people. There's also a suspicion that he had a girlfriend who might have helped him with his work.
Mileva Merrick, his wife.
It was his wife.
It was his fellow student at Zurich Polytech. And there's a whole, again, with someone with these kind of achievements, there's always this kind of undercurrent of, well, maybe his wife was the brains behind the, and we're never going to know. I mean, needless to say, they met in class. She must have been an exceptional woman. Can you imagine?
The only woman in her class.
Yeah. I mean, she was a very, very bright person. Whether she could have helped him in 1905 when he formulated, that miracle year where he came up with E equals MC squared, special relativity, quantum theory, and the Brownian motion paper, which helped prove the existence of atoms. And you're going, 1905, they must have known about atoms. Well, actually, you needed a guy to statistically prove it. And that's one of the things that Einstein did in that year. So, I'm sure that they bounce things off of each other's heads.
And the thing about trains, the movement of trains in time, can you talk about that, how that helped him?
Well,
knowing about train movements, and that's what he did when he was in Bern, right? He worked train schedules.
I mean, he was not an easy guy, and the professors at Zurich didn't like him. They thought he was kind of a smart ass, and so he couldn't get an assistantship. So he's basically boxed out of the academic structure at that point. So he's starving. He's doing some tutoring, and then he finally says, well, a friend intervenes and gets him a job as patent clerk, third class in Bern in Switzerland. And so he's reviewing tons and tons of patent applications. Unfortunately, the Swiss, with their great efficiency, they've destroyed all the patent applications with his handwritten notes that he must have done from 1905 to 1908. Can you imagine if we actually found those things? They're gone. But one of the things that was going on was, the railway trying to link up, if a train in Berlin is coming in at 10:15, what does that mean if you're in Paris? You had to have a way of kind of gauging the simultaneity of train travel across large distances. So he was being exposed to time, the problems inherent in time. And I don't know what percolates in the mind of a genius for all times, but he finally started to come up. This was a basis of special relativity, in which he was saying every observer has his own frame of reference, time frame. That's a nice thing to say. What does that mean? That means the classic picture is if you're an observer on a train embankment and there's a train car that's moving past you, and lightning hits each end of the train car, well, you're going to say, simultaneous. The lightning simultaneous hitting each end of that moving train car. You're going to say, well, it happened simultaneously. The observer in the train car is not going to see that. The train has moved infinitesimally forward. It's moving along. And so the first lightning, the strike at the front, you're going to see it before you see the strike at the back. So now you don't have the simultaneity that the observer on the embankment. And Einstein goes, you see, there's no right framework. There's no constant universal time. Like Newton thought time was universal through, but Einstein said, no, it's the observer. I mean, this is a very thoughtful guy who, by the way, is not, in a PhD program. Right. He's grinding out the patent applications, right. And he writes these papers. He writes 5 or 6 papers in 1905, and, the most preeminent physics journals, the Annalen der Physik, published them. The closest you can probably come to it is maybe Newton after he left London with the plague in the 1600s, that he put together the idea of gravitation and the idea of the calculus. But to have 4, 5, 6 things like that in 1 year, it's like how
Without
did that
mentoring,
happen?
really no mentoring at all.
Yeah. Now maybe that's the secret though, not to have the mentoring. Because the German system was, do it my way. I'm the Geheimrat professor. This is what we do in my lab. Einstein is a free agent and left to his own theories. He's only got himself to talk to.
I guess the German way was to do the experiment, and if it didn't work, believe the theory. Einstein's way was do the experiment, and the result would change. And if it worked the way the experiment worked, then throw the theory out if it didn't fit the experiment.
Absolutely. And by the way, his lab was his head. It was the thought experiments, the Gedanken experiments. But he had a great intuitive sense of physics, and so he could think about, couch this in terms of what observer on the embankment looking at trains going by, or what it's like if somebody falls off a roof, how they experience gravity, things like that. So he had a great visceral sense of the physics. And that's where it probably got harder for him, is when you get into things like the theory of everything, quantum mechanics and general relativity. You don't have an intuitive, visceral gut feeling for for the curvature of space-time, things like that. And so now he had to rely on mathematical formalisms. And he had to learn the math as he went along. At first, early in his career, he said, I don't need the math. I can, if you spirit theory of special relativity, somebody who knows a little bit about algebra can deal with that. Yeah. But you get to this later abstruse things like general relativity, you got to know some serious math, tensor calculus, non-Euclidean geometry. I can say these things, I don't understand them, but I'm going to tell you he had to learn those. But those are not something that you experience, seat of the pants kind of experiences. So that may have been why it was harder for him. Once he got past general relativity in 1915, it was harder for him